Alrighty, hello everyone, it's Jonathyn, and I'm here with Dr. Rob Koons to talk about a subject that doesn't get talked a lot about, at least in the circles that I look in on YouTube. And we're here to talk about hylomorphism and quantum mechanics. But before we get into that, just Dr. Koons, maybe if you want to give your background, your specialties, anything like that.
Sure. So I teach philosophy at the University of Texas at Austin, where I've been for 35 years. I had some graduate degrees from Oxford and UCLA. And my work has been in a number of areas, starting out in philosophy of logic, but then more recently in metaphysics, philosophy of religion, areas of that sort. And as you alluded to, last 8 years or so, I've been working pretty intensively on the metaphysics of quantum theory.
Awesome. And you mentioned philosophy and science in there. Can you briefly, for people who might not know, like what are how do you conceive of philosophy and science and the relationship between the two?
Right. So in the broadest sense, I think the two words mean roughly the same thing, which is our knowledge or our study, our investigation of reality. And the study of the world of space and time, what we might call the created world, is traditionally been called natural philosophy. So Isaac Newton had the chair of natural philosophy at Cambridge. But in modern times, we tend to distinguish science and philosophy, where science has come to refer to, I would say, a number of special fields like physics, chemistry, biology, geology, taken as a whole. So what's happened historically, I think, is that as people make progress in understanding the world, people begin specializing. Right? So people start focusing on physical objects, chemical substances, living things, and they find their own methods and their own approaches to those subjects. So we eventually call those sciences. And science has become now a term for all those special sciences taken as a group. So philosophy is whatever's left over from that, right? So it tends to be the study of reality in its most general and most fundamental respects, which we call metaphysics, and also some of the human phenomena the sciences don't focus on, like the theory of knowledge, epistemology, theory of value, ethics, beauty, aesthetics, and so on, truth, logic, and whatnot. So that's roughly how I would distinguish the two.
And so in philosophy, we're doing a lot, especially in metaphysics, we're doing a lot of like what people call theorizing. What makes for a good, broadly like philosophical theory, and does that match up with how we conceive of like a good scientific theory?
I think it does, roughly. I think that essentially the same virtues that you look for in a scientific theory, you're going to look for in a philosophical theory. So you want the theory to fit the data. You don't want it to be contradicted by the data. Now, the difference here, I think, is that a philosophical theory is going to be looking at data in a very, very broad way. Basically, everything that we know counts as data for a philosophical theory. Whereas in physics, we have a much narrower band of data that we're considering, things that we can measure in a laboratory or observe in certain kinds of very carefully controlled circumstances. For philosophy, we consider things that we would call like common sense, our common experience as human beings, all providing data for our philosophical theories. But then beyond that, there's a number of similarities. I mean, we want a theory that gives reasonable answers to the big questions of the field. In philosophy, that's the big questions of life. And we want the theory to be self-consistent and free of anomalies. And we would prefer a relatively simple theory, right? One that doesn't complicate things beyond what's needed to account for the data.
Yeah, and that would include quantitative and qualitative simplicity, because there's this idea of like,
Right.
Do we want two kinds of a couple things, or do we want one kind, but we have many things within that kind? Is there a primacy to either quantitative or qualitative, or do you view them as more or less equal?
No, it's a really good question. I would say in general, qualitative is more important than quantitative. So the analogy that I like to use is in the science of chemistry, where initially we just worked out that there were elements, right? 92 originally elements in the periodic table. And so Dalton and others conjectured, rightly, that there were atoms, kinds of atoms that correspond to each element. There are iron atoms, there's oxygen atoms, and helium atoms, and so on, right? And that was a huge step forward, right? Because before that, we had thousands of different kinds of materials, and now we could simplify that in terms of atoms. Of course, there's lots and lots of atoms because they're really small, but there were only 92 different kinds. And then when we got to the subatomic theory with Rutherford and others, we said, well, actually, there's just 3 fundamental particles here: electrons, protons, and neutrons. And in terms of those, we can explain all 92, and actually more than that, of the different kinds of atoms. So, of course, there's lots more electrons and protons and neutrons than there are atoms. So quantitatively, it's a step backwards, but qualitatively, it was a huge step forward because you went from 92 basic things to 3 basic things, and that was a much simpler theory.
Okay, awesome. So to get right into it, what is hylomorphism? And I know there are different people who call themselves hylomorphists. They have different views. I think I've read you have a paper on this. Well, what is hylomorphism, and what's the sketch of the general views within it?
Right. Good. So it refers to a program in philosophy, in metaphysics, in the philosophy of nature that goes back to Aristotle, especially, and Aristotle's philosophical and scientific works, and all the followers of Aristotle, which stretches from the 5th century BC right up to the present time. So it's a long, ongoing kind of tradition. So there are a number of different characteristics here. The word hylomorphism suggests one of them, which is the prominence of these ideas of matter. Hylo means matter. Morphe is Greek for one Greek word for form. So things, natural things, are in some sense to be explained intrinsically, explained in terms of components or factors that can be called matter and form. The word matter, actually, as we use it in today, originates from Aristotle. He's the first one to coin a term for matter. The word hule meant something like lumber in ancient Greek. So he was suggesting that the things of the world are made up of other things or stuff, which we can call matter. And then in addition to that, there's something he calls form. Again, there's a number of different Greek words he uses for that. Eidos is perhaps the most common. So I guess we might step back here a little bit and say, first of all, Aristotle is imagining that we can identify certain kinds of fundamental things in the world, the fundamental building blocks of the world, which he calls substances. That's the Latin term, ousia in the Greek, substances. And so the world is made up fundamentally of substances. And then, of course, there are parts of substances, and then there are heaps of substances, and so on. But the key building blocks are these substances, right? So, and for Aristotle, these substances are all composite things. That is, they're not simple microscopic particles. It's rather things like you and me, and maybe stars and planets, and large bodies of water, and so on, that are the fundamental building blocks of reality, right? So therefore, Aristotle has to propose that there's something he calls form, which gives to these substances their unity, that makes them one thing, and that gives them their nature. It gives them their potentialities to act in the way they do. There's another very important concept for Aristotle, is the idea of potentiality, distinction between how things actually are and how they potentially could be. And the nature is what defines that realm of potentialities. So it tells you how a thing interacts with other things, how substances interact with each other. That's going to be determined by these natures, which are in turn determined by their forms. So where does matter come in? Well, as I say, typically substances are composite things for Aristotle. So I've got cells, I've got molecules, I've got atoms and particles, right, that make up my body. All of those could be considered collectively my matter in various respects. And so the matter is also something from which a substance can be formed initially. So substances can be created and destroyed in Aristotle's picture. They're not eternal or indestructible things. They come into being and they go out of existence. When they come into being, it's because some agent, some maker, is acting on some pre-existing stuff, substances perhaps, and giving them a form, which then creates a new substance. So the new substance is being formed from pre-existing stuff It's called the matter. And when a substance ceases to exist, when it dissolves back into its elemental pieces, so to speak, again, it dissolves back into matter. So matter is a kind of substrate here for creation and destruction, right? But it also, it exists while the substance is in existence, right? The thing has its matter, which represent its parts, so to speak. Now, one issue that's somewhat controversial in understanding Aristotle is whether we should posit something called prime matter, right? So prime matter would be something which really has no nature of its own at all, which is a kind of pure potentiality to be formed in all kinds of different ways. There's some controversy about whether Aristotle himself believed in prime matter. Some people in the Aristotelian tradition have rejected it, but I think the mainstream has thought that yes, you need a notion of prime matter as well as matter as a kind of limiting concept. But the key idea here is that for an Aristotelian, you're never going to discover prime matter on its own, right? You're never going to be able to isolate just pure prime matter, so to speak, because matter is always the matter of something, of a substance, right? As form is always the form of a substance, at least in the material universe that we live in. Form and matter are going to be inseparable from each other, right? Now, prime matter is actually close in some ways to the modern concept of energy, right? So there's at least an analogy here. We have energy can be in a chemical form, it can be in a kinetic form, it can be in the form of gravitational potential, and so on. So it can take all these different nuclear energy, it can take all these different forms, but presumably there's some kind of underlying stuff, right, which can be transformed from one kind to the other, right? That's getting close to prime matter. I say prime matter is even barer than pure energy because it's energy has a kind of quantity to it. Every system of energy or quantity of energy has a certain measure, so many joules of energy, whereas prime matter is even more fundamental than that. It lacks even a quantity. So prime matter would be the thing that has the quantity of energy, which then becomes a certain chunk of energy, so to speak, in the world. But then there's an analogy here, I think, which is you could never discover energy as just pure energy. It's always the energy. It's always going to be kinetic energy or chemical energy or some other kind of form of energy. It's always going to be combined with some form or other. And that's certainly the view of the case for matter in the Aristotelian picture of things. So that's one of the key ideas. The other thing, maybe two other ideas here that's important. I mean, one I think I've already alluded to, which is that Aristotle's system is holistic rather than atomistic. So the substances of the world are composite things as opposed to microscopic simple things, right? So already in Aristotle's day, we had these two competing models. There was Aristotle's model, and then there was the atomistic model of people like Democritus. And then there's also a view like Empedocles, where there weren't actually atoms, but still there were really, really, really small bits of earth, air, and fire. And those were the fundamental things. And everything else, the larger sort of things like you and me, are just byproducts or epiphenomena, as we put it in philosophy. That is, they're just ways of describing what's really going on at the microscopic level, right? But in a kind of crude, rough and ready sort of way. Whereas for Aristotle, no, it's actually the composite things, like organisms, that are fundamental. And the microscopic parts are dependent upon the whole. So there's a dependency of the parts on the whole in Aristotle's picture. The whole is more than the sum of its parts, as people put it. That's a crucial element in Aristotle's kind of picture. And as a result of that, finally, you get what Aristotle calls teleology, or final causation in nature. This is because things have form, which give them a certain nature. And that nature enables those things to act and interact in certain characteristic ways. And we can then define a kind of perfection for each substance when it's able to exercise its potentialities fully actualize its potentialities. It's in the state of perfection. And that's the way the thing is supposed to be, right? That's the sort of end or purpose for which it exists. It's sort of clear to see how, I think it's easy to see how that works in the biological realm, right? If a plant or an animal is flourishing, right? and it's healthy, and it's doing its characteristic things, and it's with its environment. It's in a state of perfection, and it's the way things are supposed to be for that kind of organism. And if it's damaged or ill or whatever, it's in a state of imperfection. It's being frustrated, and it's achieving its end. And that, for Aristotle, is a fundamental part of the world. It's not just some kind of useful fiction or something. On the other hand, I mean, we don't want to suppose that Aristotle's imagining that, the tree is actually feeling an urge to, engage in photosynthesis or something like that. It's not that he's a kind of panpsychist, as though he's attributing feelings and consciousness to plants or even to inorganic things. It's rather that every kind of substance for Aristotle, whether alive or not alive, is tending in a certain direction, and in that sense striving towards a certain definite end in the end.
All right. Now with forms, I think because obviously Plato talked about forms, and right. So did Aristotle, but they had two very, at least in contemporary interpretation, they had two very different pictures of what they are.
Yeah.
So would you say forms are like a universal, or would you say they're an individual of a kind or something? Like how would you differentiate that?
Yeah, so this is an area where there is going to be some difference among people that might call themselves Aristotelians or hylomorphists. So just to simplify things, I'll give you my view, which is, I think, well, certainly Thomas's view, Thomas Aquinas' view, and it's also at least one very plausible interpretation of this tradition. And on this view, forms are indeed particular things, in a sense that I have a human form, you have a human form, President Biden has a human form, and so on. And each of these forms are numerically distinct from each other. In contrast to Plato's picture, I think, where in Plato's view, there's a single human form, right? The human itself, right? And then each of us who are human somehow participate in that human form. Maybe we have a part of it or whatever, right? That's one of the difficulties for Plato, is to work out exactly what that relationship is supposed to be between individual humans and this human form. I think, but on the other hand, I mean, Aristotle's view is definitely related to Plato's, a kind of successor of Plato's theory in various ways, because although we each have our own individual forms, those forms are not distinct from each other in and of themselves. They're not fundamentally distinct from each other. They're made distinct by their connection to different chunks of matter. So as I understand it, in Aristotle's picture, chunks of matter, prime matter, these are the things that are fundamentally distinct from each other, but lacking any kind of nature or quality or character. But they're fundamentally distinct. They're kind of a field of distinctness out there, so to speak. Then the forms come along and give natures or characters to these bits of prime matter. But where you have two forms of the same species, same kind, like two human beings, the forms would be identical, except for the fact that they've been combined with different chunks of matter. So the matter individuates the form. It's the technical term from the Middle Ages. It makes the forms individual, right? So there is a natural unity to all human forms, in the sense that they all would be one, as Plato thought they were, if it weren't for the fact that they're attached to different chunks of matter that individuate them, right? And so it's not just some kind of it's not some subjective thing or conventional thing that we count me and you and Biden and others as humans. There's a metaphysical foundation for our being part of a single species, which is that we have forms which have this kind of would-be identical relationship to each other, right? That are individuated by bits of the prime matter. Whereas, let's say, if you look at my form and the form of a dog or a tree, those two forms are intrinsically different. Right? My form is intrinsically different from the tree's form. It's not made different by the matter that the two forms are attached to, but intrinsically different because they're different. Differentia is the term that Aristotle used. That is, I'm rational and sentient, and the tree isn't sentient or rational, right? So the forms are intrinsically different there. But among human beings, the forms are all intrinsically the same, and they're only distinct by virtue of being attached to different chunks of matter. So that, I think, is different from Plato, although Plato is moving in this direction in his later work, actually. I don't think it's such a big jump as a lot of people think it might be.
Yeah, so it'd be correct to say that forms are kind of these individual actualities that are, if they're of the same kind, they're only distinct in virtue of these kind of bits of matter, right? If you want to call them that.
Right.
That they and the forms actually do actualize the matter in a particular way.
That's right. Mm-hmm. That's right. That's right. Very good. Yeah, prime matter, in a sense, has the potentiality to be actualized in any way whatsoever, any kind of nature. And what the prime matter contributes is the individuality of the thing, right? It individuates the members of the species.
Okay, and I think in one of your papers you talk about forms being logically simple, or something like that, or metaphysically simple. Can you explain that briefly?
Yeah, I'll try to. So this is slightly complicated. So I'm a human being, right? So are you, and that's a certain kind of animal, right? It's a rational animal of a certain kind, right? So on the one hand, I have something in common with all the other animals, namely being animal, but I have something that differentiates me from them, namely being rational. So if I compare myself to a chimpanzee, let's say, or to a dog, my form and its form are intrinsically different in some way, right? So now the question is, well, how are they the same? What makes us both animals, right, if we have forms that are intrinsically different? Right? What groups us together as animals as opposed to just substances in general, right? That's the problem. And one possible view would be to say, well, maybe I have multiple forms. I actually have an animal form and a rational form, or animal form and a human form. So I've got a living organism form, and I've got an animal form, and then I've got a human form, or something like that. I've got some kind of plurality of forms, right, of this kind. The difficulty then is that what makes me one thing, right? If I've got an animal form, well, animal form, that should be enough to make me one thing, right? And then I've also got this human form. Well, wait a minute. I mean, am I essentially an animal, or full stop, or am I essentially human, right? There's got to be only one form that's really got to be responsible for making me me and giving me my nature. So I think the answer is that I just have one form. And it is intrinsically different from the forms of other animals, right? But again, there's some kind of, in this case, not matter, but certain characteristics that we call differentia, which are responsible for making me different, right? So let's say the horse is a fleet-footed animal, right? Just to simplify, I suppose that's the differentia of horsiness. And I'm a rational animal, right? Well, if fleet-footedness and rationality were the same, then our forms would be intrinsically the same, right? And that's what makes them animal, right? So they are individuated not by matter now, but by differentia, and it's that groups them into the category of animal. And then likewise, what makes me a living thing? Right? Well, what makes me a living thing is that what individuates me from plants is the fact that I'm sentient, as opposed to planty, or whatever plants are, right? Whatever their differentia is. If sentience and plantiness were the same, then my form would be intrinsically just like the oak tree's form, right? So there's kind of a cascade of forms of differentiation, right, that take place. At the bottom level, prime matter differentiating the members of a species. One step up, some differentiating the different species in a larger genus. Another step up, another set of broader differentiating that genus from other genera, and so on, right? So it's still the case that each substance has just one form, right? But the question is, why is this form different from that form, right? That has different sorts of answers, depending on whether you're talking about two things in the same species, or the same genus, or the same supergenus, or whatever. And so that's what gives you this, what we call a Porphyrian tree, this picture of, a big division at the very top, like material, immaterial, plants, and living, non-living, plants, animals, and so on, right? So that's That's the story I give.
And so there would be differentia for, like, if you had two chimpanzees and they both had only one hand or something, or they both had a red, whatever, they had a red like shirt on or something. So I'll put a shirt on this monkey. There would be a differentia even for those accidental forms or properties as well.
Okay. Yeah. Right. So yeah, it gets a little bit complicated. Accidental properties are going to be individuated in two different ways, right? So suppose I've got, let's say, a chunk of quartz that's pink and one that's white, okay? And they're both quartz, so they both have the same specific nature, but they've got these two different accidents, pink and whiteness, right? So in that case, the accidents are actually individuated intrinsically by themselves, right? They are what we call contraries within the category of accidents, right? Whereas if I had two pink quartzes, right? So they're both quartz and they're both pink in the same way. Now the pinkness of each of the two bits of quartz is going to be individuated by the two bits of quartz, right? So the two bits of quartz will be distinct because of their prime matter. And then because they're distinct, their pinkness will be distinct as well, right? So some accidents are differentiated by their substances, right? And others are intrinsically differentiated from each other because they're contraries of each other, let's say, like black, white, pink, white, and so on.
Okay. One last thing before getting on to maybe some of the justifications for this is, I know there's the category of substantial versus accidental form. We kind of been touching on that. How do we exactly, because I understand substantial form is like the form that makes, this whole substance, this kind of substance, or however you want to phrase it.
Right.
But then accidental forms, like, what's the exact, I guess, difference conceptually between them? Because it seems like there could be some fuzzy area where someone could put some pushback on that.
Right. Yeah. So substantial forms are the things that are responsible, again, for dividing the world up into these basic building blocks we call substances. Right? So substantial form gives the unity and the nature to each substance. And each substance has just one substantial form that does that. Then, of course, forms can change. Substances can change over time, both qualitatively and quantitatively. Right? I can get darker because I'm in the sun a lot more in the summer. I can get heavier if I eat too much, right? So those changes are changes in what we call accidental forms, right? And the accidents presuppose the substance. Right? Only substances can be colored or have a certain amount of weight or be located somewhere in space and so on, right? So the accidents depend upon the substances. The substances don't depend on the accidents in that same way. They have a form that's attached directly to matter, maybe even to prime matter, ultimately.
And
accidents attach to substances.
What would be a working definition of substance? Because I know Brouwer talks about it being like a subsisting individual or something like that. Would you agree with that definition, or what would a working definition be of a substance as opposed to like something else? Because I know Aristotle says it's that which doesn't inhere in another. It's like a functional definition. How would you?
Yeah, right. Yeah, I mean, I think it is difficult to give a definition here, except within the theory itself, right? So, I mean, I guess you can, unless you do it functionally, and say, well, what is this concept of substance doing for Aristotle's theory, right? And I think what it's doing again is it's giving you the fundamental entities of the world, not. Obviously, there's always the issue of how God fits into this, right? Since, I mean, everything depends on God, obviously. So if we say that, substance is something that's absolutely independent of everything else, then of course that's going to be nothing but God, because we're all sort of radically dependent on God in various ways. But the thought is that, within setting God aside for a moment, right, and looking not at causal dependency, because obviously I causally, my life depends on oxygen and the environment being the right temperature and so on. I don't want that to be a challenge to my being a substance, but rather, it's that there's nothing outside of me that's needed to metaphysically explain me, right? The way I am. And something like that, I think, is the way you pick out substances.
So it's something that can be a substance, something that can be explained why it is that way within its own being or within its own parts.
Yeah, that's right.
Okay.
It sort of has a self-contained definition, as Aristotle puts it, where a definition isn't defining a word, but defining the thing itself. Why is the thing this kind of thing, and why is it this way?
Awesome. And what are some of the basic, I guess, because there are other views of change out there. What's the kind of, I know it's very complex and there's a lot of literature on it. What do you think are the best arguments for this kind of hylomorphism as opposed to some other view about change?
Yeah, right. Good. Yeah, I think that you're right to focus on change, actually, because that's one of the big dividing points in philosophy of nature and metaphysics more generally, how to understand change. So to put it real simply, I think you could suppose that you could say there's basically two sorts of pictures: Aristotle's picture and a picture in which time is something like a fourth dimension, like a spatial dimension. And on that second view, which has become quite popular in the modern world, you get what's called the at theory of change, right? So if a iron rod goes from being cold to hot, we can say that all that means is that at this time it was cold, and at this later time it is hot, right? So there's just a kind of four-dimensional structure, right? Four-dimensional block, so to speak, right? Of 3 dimensions of space and 1 dimension of time. And then across that block of space-time, there are a bunch of qualities that are distributed, right? And maybe the spatial bits have some kind of measure, and maybe the temporal bits have some kind of measure as well, right? And then change is just a matter of, as you go down the block from one end to the other, right, you pass through different regions of quality, right? And the way the qualities are distributed are changing, so to speak, as you pass through it, right? But the block itself isn't really changing; it's just sort of sitting there, right, in its four dimensionality, and it's only changing in the sense that if I said, it gets hillier when you drive west from Austin, I don't actually mean, that hills start popping up literally, right, that were flat before. What I mean is, as you go west, right, you go from flat land to hilly land. And so likewise, if I say the universe is getting, more entropy, all I'm saying is as you go down this temporal dimension from earlier to later, you go from states of lower entropy to higher entropy, right? There's not really a change. Right? On the Aristotelian picture, on the other hand, change is the more fundamental concept. Time is just the measure of change. So you can't define change as at, right? One way at one time, another way at a later time, because time itself is going to be defined in terms of change. So for Aristotle, change occurs when two substances interact with each other in such a way that one actualizes some potentiality of the other that was not yet actualized. Right? And so that's the picture that Aristotle gives. Now, there are a number of advantages to Aristotle's picture. One, I think, very big advantage is that he gets a natural direction to time, right? Because every change for Aristotle is always an actualizing of a potential, right? And so when the potential is not actualized, that's earlier. When it is actualized, that's later. Right? So every action involves a certain direction. Right? And so time is just defined by that direction of change. Whereas on the other picture, I guess we could call it sort of Humean picture or quasi-Humean picture based on early work by David Hume. There's no intrinsic direction to time or to causation for that matter, right? There's just one damn thing after another, as Stephen Barr puts in his latest book, right? Just quality, different quality, and so on as you go down this temporal dimension. And so it seems that it's hard to define a direction. There have been attempts to do so in various ways by Humeans, but I don't think any of them have succeeded. Some would say that, we define the direction of time by the second law of thermodynamics or something like that. So, you find the dimension along which entropy is increasing, and that's the direction in which time is flowing. But that there are a number of different problems with that, right? I mean, it seems like it's easy to imagine, at least really simple worlds, where time is passing, but entropy isn't increasing or decreasing. It's just steady state. It's easy to imagine that. And so, it's counterintuitive to say no, that's impossible. It's also quite easy to imagine worlds where entropy is increasing in certain bits and decreasing in other places at the same time. Do we really want to say that time is flowing in different directions in different places in the same universe? That seems pretty hard to grasp as well. And then there's other difficulties with the neo-Humean kind of picture.
All right. Oh, go ahead.
Another sort of problem here is that this maybe gets ahead of ourselves a little bit. Often people criticize Aristotle for positing or including in his theory lots of things that are unobservable and somewhat mysterious. So, I've already talked about substantial form and matter, prime matter. Those are both, unobservable in some sense. It's a little mysterious in some ways. Some philosophers just object to the whole idea of powers and potentialities themselves as being mysterious. Right? So if I say the water has this power of freezing when you get it to 0 degrees centigrade, I say, what does that mean? Right? The Humean says, well, all that really means is if you look at the history of the universe, whenever water gets to 0 degrees centigrade, later on you see ice. That's right. So we don't really need powers, right? All we have to have is this pattern of behavior across space and time. So we can get rid of all this mysterious Aristotelian stuff. Right? And the Aristotelian pushback is going to say, look, that's just not satisfying, this Humean answer. It doesn't really capture what we think is going on when ice freezes. Right? It's not just there was water and now there's ice. End of story, right? We really think that there's something about the potentiality of water to freeze that's been actualized. Related to this, of course, is the problem, I think, of induction, or how scientific knowledge itself is possible. And the Humean picture, where there's no powers out there, no real potentialities, just one thing after another, they really, not only they can not explain how we have inductive knowledge, they actually give really good arguments to the skeptic why inductive knowledge should be impossible. Because, we've seen only a very small part of the history of our universe. If we consider all the possible ways that universe could go on in the future, the vast majority of them will be crazy ways, which will falsify all the things we thought were laws of nature. And the Humean has no reason to think that the universe is going to go on in the same way. There's nothing, in fact, he or she should treat all of these different ways as equally on a par metaphysically. And so there's really strong reason to be a skeptic, really strong reason to think it's really, really unlikely that, that the run of luck we've had so far will continue any further, right? That the laws of nature will really continue to be stable. Whereas again, the Aristotelian story, it's willing to take on more theory. It's willing to accept that there really are these natures, and these natures give rise to powers and potentialities. And those things undergird and explain why nature acts so regularly, right? Why at least opens up the possibility that we could know what the future is like based on the past.
And I think another argument that I think it's the whole thing is an argument, is how you understand quantum mechanics in its relation to hylomorphism. Yeah. Because I think you would say hylomorphism best explains what we see at the quantum level. For those who don't know, and for people like me who are not very well versed in like science and things like this, what is quantum mechanics generally speaking, and maybe how did it come about, and then we could get into the other stuff about hylomorphism.
Good. Yeah. So if we go back to the late 19th century, physicists thought they had pretty much figured everything out, right? They had Newton's laws of motion, they had Newton's theory of gravity, and they had Maxwell's theories of electromagnetism, which included light, as well as electricity and magnetism and all that stuff. And so it looked like, you could explain everything in the natural world using these relatively simple mathematical formulas governing the motion of matter. Great, right? Then they discovered subatomic particles, right, and the atom. And Rutherford and others figured out, okay, there's the electrons spinning around this nucleus, right? And okay, we've got a lot of problems here, right? Because first of all, the nucleus is a bunch of positively charged protons packed together. They should they should fly out, right? But that's the smallest of all the problems. The bigger problem was you have electrons. The thought was that they're kind of orbiting around the nucleus, right? Because they're attracted to the nucleus because the electrons are negative and the nucleus is positive, right? So there's electromagnetic attraction there, but they're moving, so they're just like a planet going around the sun. That was the idea. But then Maxwell's theory says, oh, but if you have an electron going around this nucleus, it should be constantly emitting electromagnetic radiation. It should spiral in and bam, reach the nucleus in a very short order. So there's no way that you could explain how atoms are possible, right? Given the 19th century classical physics. So it's back to the drawing board, right? What's going on? And what they discovered, Max Planck and others discovered, is that lots of weird stuff happens at the microscopic level. The reason it's called quantum theory or quantum mechanics is they discovered that things at that level don't vary continuously in their energy. Right? Like, you know, if a car is gradually accelerating, right, its kinetic energy is smoothly increasing as a kind of continuous function. Subatomic particles don't work that way. They have to occupy certain quantized levels of energy, and they sort of jump from one to the other. And this is what gives us the different shells within an atom. It's why electrons can't just spiral into the nucleus, because they have to stick to their shell and that level of energy, and they can only go down if there's an empty shell inside there, and there's only a finite number of those. So once they get filled up, you get a stable atom. That's the story. Okay, so far so good. Okay, that makes sense. But then it turns out that once you chart, you can't just get to this solution in a very simple way. You really do have to go back to square one and rework the laws of nature. And what they discovered was that you can no longer describe the microscopic world in terms of particles moving through space, according to some kind of law of motion. That just doesn't work. What you have instead are laws of nature which describe how probabilities change over time. Right? Really weird, right? Wait a minute, this is like totally different from Newton-Maxwell kind of physics, right? It's not particles moving through space, it's probabilities evolving through a kind of what's called a state space, where you have a multi-dimensional space that describes all the different ways that these particles could be arranged in terms of motion and position. And then you define a probability function on top of that space. And then that probability function is what's evolving over time in a deterministic way according to mathematical formulas. Okay, so it's really radically different kind of a picture. Now this has a number of really profound implications, right? One is particles lose their individual identities, because you can no longer pick out this electron moving through space over time. Instead, you just get a probability function of where you might find electrons in the future, right? So there's no individual electrons anymore. There's just a kind of cloud of electron potentiality out there, right? Very different from the kind of atomistic picture that you would expect, right? If you were an atomist, you'd expect that once you get to the microscopic level, things should be more and more definite, right? We'll find out exactly where the atoms are, the particles are, how they're moving, and that'll settle everything else. No, you find out instead, you get these clouds of probability and potentiality down there. Everything's very indeterminate, not more precise and more definite. In fact, less so as you go down to that level. This quickly leads to two more problems. One is what's called the locality problem. So because you don't have individual particles moving through space and time anymore, but probabilities evolving, right? It turns out that the probability of an event at one place at one time can no longer be determined by what's going on in that place and time, right? But could depend in principle on anything anywhere in the universe. So it's a radically non-local kind of universe at the quantum level. What's going on at the opposite side of the universe right now could affect which way an electron goes, so to speak, what the probabilities are of observing an electron here and now, right? That's a very, very radical consequence. And that leads to a further problem, which is called the measurement problem. So again, if you look at the fundamental laws of quantum mechanics, it's called the Schrodinger equation. Again, what it tells you is not where particles are, but what the probability is of observing an electron at a particular place in time, or some other kind of particle. But quantum mechanics doesn't tell you what observing means. It gives you probabilities of measurements, but doesn't tell you what measurements are, right? And that's a huge problem, right? In a sense, it's quantum theory is saying, I can't possibly be a complete theory of the universe, right? Because I'm telling you that, at the microscopic level, what's happening is an evolution of probabilities of blah, right? And what's blah? I don't know. It's not something in the quantum world. It's something outside the quantum world entirely. Totally nothing like that ever happened in Newton's theory or Maxwell theory, right? It's a radical kind of change. A great example of this, of course, is the Schrodinger Cat problem. So you have let's say a bit of radium that may or may not decay. Let's say it's a quantum event, and so the quantum mechanics says 60% chance it'll decay, 40% chance no decay. Okay, then you attach this to a cat. So if decay happens, the cat gets electrocuted and dies. If there's no decay, the cat lives. Okay, so fine. So no problem, right? 60% cat lives, 40% the cat dies. But the problem is that if you say, wait a minute, the cat is itself a bunch of quantum particles. Well, if the cat itself is a bunch of quantum particles, then you don't get 60% live, 40% dead. Instead, you don't get a measurement. You just get the cat as part of the larger probability wave, right? So in other words, what the system doesn't tell you, there's a 60% chance that the cat will be alive, 40% dead. It says there's a 100% chance the cat will be in a 60-40 superposition state. So the cat will go into a kind of superposition state, just like the radium atom was originally. So the indeterminacy of the quantum level seems to just expand to include everything in the universe, right? Because we're all made of quantum particles. This is the problem. And so you actually get a contradiction. Right? The theory says there's a certain probability of a definite result. And it also says, well, wait a minute, there's no definite results. You never get any definite results because everything's quantum. So the only way to get around that is to say, okay, everything isn't quantum. There's got to be some non-quantum stuff out there somewhere. Right? And this is really tailor-made for hylomorphism, for Aristotle to come to the rescue and say, look, the problem is you thought that the attributes of a cat or of me are determined by our particles, but they aren't, right? We have substantial form and we have accidents that are holistic in character, that are irreducibly biological and chemical and so on, and that superimpose structure on the quantum world, right? And so once you say that, okay, the quantum world isn't the whole shebang, it's just a way of describing the microscopic aspects of substances, then the problem disappears. The cat is either alive or dead, right? Because that's not a quantum event, right? That's a non-quantum level property of being alive or not being alive, right? That's something that occurs at the level of substantial form in this particular case, right? And so you solve that problem. There's actually some physicists working on this. George Ellis and Barbara Drossel have written a couple of articles recently, and they're not hylomorphists. They don't really know Aristotle that well, but the version of the theory of quantity theory that they've developed fits exactly the kind of picture I'm describing. That is, that there's a non-quantal aspect of the world, right? That you see at the macroscopic level, in particular, living things and the chemically thermodynamically stable instruments that we use to interact with the quantum world, right? They have properties that are not reducible to the quantum level, that are more than what could be described in quantum mechanical terms, right? And that's exactly what you need to solve these two crucial problems. The other thing I've been working on that's related to this is that, again, in pre-quantum science, it looked as though chemistry and thermodynamics were just physics, applied physics, right? Once you figured out what was going on at the level of the molecules and the atoms, that would tell you everything you need to know about chemistry or thermodynamics. And in quantum mechanics, that's no longer the case. Right? In thermodynamics, you have to go outside the quantum realm in order to find things like chemical form or temperature or entropy. These things have to be imposed upon the quantum world from the top down. And that's exactly what Aristotelians would have thought, that kind of thing. It's exactly the kind of top-down formal causation that's been part of the Aristotelian tradition all along. And
would it kind of be like, take a human being? You couldn't know everything about that being by just analyzing like some fundamental components of its body or something. You'd have to start from it as a substance, as a composite, and then work your way down. Is that kind of what you're saying, like conceptually?
that's right.
And causally?
That's right. I mean, and we actually, and this is just a worry. I mean, there are actual theorems. There's something called the Stone-von Neumann theorem that shows that that quantum systems cannot have thermodynamic properties or chemical properties. They have to come from the outside, so to speak. So it's not just me. It's even a glass of water, right? The water in the glass has certain chemical properties and a temperature and so on that you could not deduce from a purely quantum mechanical description of the particles that make up the water, right? Even if you were, don't worry about computational limitations. You have the supercomputer, this Laplacian intellect that can calculate, infinitely fast, and you give it all the information that you want to give it at a quantum mechanical level, and then you ask, well, what's the temperature and what's the composition? Is it water or something else? You say, I don't know yet. You have to tell me more information, because at the quantum level, it just doesn't decide those issues.
So they're missing the substantial form of water.
That's
They're
right.
only analyzing kind of, I guess, the matter element of things, the physicality element of things.
That's right. Okay. That's right. They're trying to just look at the matter and go from the bottom up. Won't work. And quantum mechanics tells us it doesn't work.
With Schrodinger's cat again, because some of that flew past my head.
Yeah.
Can you explain one more time, really, how the top-down picture solves the Schrodinger's? I just want to be clear on it.
Good. Yeah. Let me try that again. Okay. So as I say, if you describe something quantum mechanically, what it does is it describes an evolving set of probabilities. Okay. And at that level, nothing definite ever happens, right? It's just particle here goes from 60% to 70%, down to 30%, 35%, and so on, right? The probability just sort of fluctuates. You never get definitely particle here, right? You just get this fluctuating set of probabilities, okay? But of course, what does that mean? Probability, 35% of what, right? Well, the way that scientists actually use it is they say, well, 35% probability that we will actually see an electron there when we look, right? So they introduce some sort of notion of observation or measurement in order to make sense of these probabilities. But then if the observer, the cat or the human observer, let's say, is himself or itself just a system of quantum particles, right, then we should extend the description from the atom that we're looking at to the whole observer himself. And now quantum mechanics says, okay, you never get a definite result, right? You just have a certain probability that he'll go one way. You'll see a dead cat, a certain probability you'll see a live cat, and that probably just keeps going on fluctuating, right? with no definite result ever. That's the problem. It's what, in technical terms, the quantum physicists call the superposition. So it means that the atom is neither definitely decayed nor definitely not decayed, but it's in a state of kind of mixture of decay and not decay with a certain probabilistic weighting attached to the two things. And if I interpret the cat or the observer as himself just a larger quantum system, then quantum mechanics says then the observer should also go into a superposition. So the observer shouldn't see any definite result either. The observer should just have a kind of mixture of seeing dead cat, seeing live cat, or seeing decayed atom, seeing no decayed atom, right, with no definite result. Eugen Wigner has this analogy. It's called Wigner's friend kind of picture, where you've got the atom decaying, and then you have the observer one looking at the observer at the atom, and then observer two interprets the atom plus observer one as a quantum system, right? And so from his perspective, observer one doesn't see anything until observer two sees him seeing something, right? Checks his notebook. Until that point, it's in a state of superposition. But then observer three can treat observer one, two, and the atom as a system. And from observer three's point of view, observer one and two don't see anything until observer three sees them, writes something down in their notebook, and so on, right?
So there is no definite probability of whether the cat will be alive or dead, because even the person looking at the box where the cat is in is themselves just a mixture of kind of seemingly random like probabilities.
Right, exactly. That's right.
And Form solves that by saying the cat isn't just a composite of quantum stuff. It's
Right.
more fundamentally form and matter. And then we can maybe talk about quantum stuff at a deeper level, but the cat is just form and matter.
Right.
Is that the idea?
That's right. So there's a quantal aspect to the cat, but there are also non-quantal aspects to the cat. And being alive or dead is a non-quantal aspect, right? And so determined by whether it has a cat form or not, right? And that has nothing to do with that isn't determined by the quantum level.
What would you say to someone who would say, well, wouldn't the form and the matter of the cat just be reducible to this kind of quantum stuff? Is that just kind of something you've built out of the theory to get you out of the problem, or is there a reason to think that independently, that the form and the matter aren't just quantum themselves, or however you put it?
Well, as I'm trying to say, it looks as though quantum mechanics says, I can't be the complete theory of the world, right? Because what quantum mechanics says is there's a certain probability of a measurement, but the measurement is not a quantum event. It's some non-quantum event, right? And so you know, whether you're a hylomorphist or not, you're going to have some kind of a doppeled world, so to speak, right? Where there's more going on than just quantum mechanics.
Right.
So
and you're saying this is the best way to do that.
I mean, I guess I'm saying, you know, we'll look at how chemistry and how biology work, right? Now we know they're not reducible to the microphysics, right? So they should be treated as real, as dealing with fundamental things in their own right. Right? And then substantial form makes sense, right? What is it that makes the water watery other than the form of water, right? Which we can then understand in terms of, you know, the particles acting at least as if they were organized into molecules in a certain way, with H2O sort of molecules and so on. But now we have to understand that as a kind of top-down process rather than just a byproduct of putting the particles in space.
Because then you're in the same problem if you do it that way.
Right.
So the form gives a kind of a definite structure to things,
right?
Including the person looking at the box with the cat in it, such that they're not in that kind of quantum a realm or layer of things.
Right. Exactly. That's right. Mm-hmm.
I had some, unless you had anything you wanted to add in about anything you missed, I had some questions kind of related to form and matter in our last, you know, four or so minutes. And I appreciate everything. And obviously in the conversation, you've kind of helped me understand some of the quantum stuff more. Because I know Aquinas would say that forms in some sense pre-exist in the mind of God in some sense. Would you see yourself agreeing with that picture? And do you think that gives you any theoretical benefits, or what's your view on that?
Yeah. So it's a good question. So, I mean, I have a little bit problem with the word pre-exist. Actually, I have two problems with the word pre-exist. Right? One is the pre part, right? Because, I mean, really, there was no time before the beginning of the Big Bang, right? God created time as well as space and matter. And so there's no, strictly speaking, it's not as though God was around before that, and that the forms could be around technically before that. But of course, you could say, well, but let's just say, you know, explanatorily prior to their existence in the world, right? Or we could ask this question: are there forms in God's mind which represent things he could have created but didn't create? Right? You know, maybe let's say there are no magnetic monopoles. I don't know if there are or not. I suppose there aren't any, but there could have been, right? And so there's a kind of a form of magnetic monopole that God could have actualized but didn't. Does that sort of exist in his mind now, right? I think, so again, my other worry is exist, right? I mean, I think I would certainly want to say that God knows every possible form, whether he decided to actualize it or not, right? So, but I don't know if that means that those things that he knows exist, right? They're merely objects of his thought or his understanding. Whereas to exist means God's given them existence, sort of actualized them. Right? So I don't think that I would have some qualms about calling that existence.
Yeah, because I was thinking, because Aquinas would say, and others would say, you can abstract universals from the particular substances, and I think Phaser talks about the forms kind of, there's a sense in which they have a dual, they have a mode of being as particular, but we can also, when we're talking about a mind, we can talk about them existing as universal.
Right.
And maybe the word exists is a little weird there.
Right.
And I was thinking this might fit well with the kind of view you have about potential identity between two individual forms, because you could say, well, if form 1 and form 2 of the same species were not individuated by matter, they wouldn't be particularized. They would just be kind of thoughts, or really the one thought of God.
Right.
In his mind.
That's right. Yeah, I think that is right. And actually, I do think that at least in the case of created intellects like you or me or angels, that a form does actually exist in some sense in our mind. So if I really get to understand what horses are, right, I would have a form of horse in my mind that would itself be would have been identical to the forms that are in actual horses,
right,
except for the fact that it's in my mind instead of in matter, right? But whether that's true for God, I'm a little bit uncertain, right? Whether I want to say that. Because my mind does work differently from God's mind. I have to have things in it in order for me to understand them. Whereas I don't think God has to do that. God's mind is absolutely simple. And the things that he understands are present to God. That's the way I prefer to put it, rather than in God, because that sort of suggests that he's got a kind of internal complexity to him.
Okay. Yeah, that's awesome. Thanks. It was just something I was kind of thinking about, this kind of divine conceptualism on the one hand and modern realism on the other.
No, it definitely does. It definitely is an advantage, I think, for Aristotle's system, that it can explain how it's possible for us to have a kind of a priori or purely intellectual understanding of things. So particular geometry, let's say, how is that possible? It's possible because the very same kind of geometrical accidents that exist in space can exist in my mind, and I can manipulate them and then gain geometrical knowledge as a result.
Awesome. I don't want to take up, I know we're a little bit past an hour. If you wanted to give any last minute thoughts or plug anything maybe you're working on, any books or articles or videos maybe.
Thanks. I do have a book that's coming out in a couple months. Its title is something like Is St. Thomas Aquinas' Philosophy of Nature Obsolete? And it actually brings together a bunch of papers that I've done on this question of hylomorphism and quantum mechanics. So it's going to come out with St. Augustine Press in a couple months. So people look for that. And it should be reasonably priced too, unlike a lot of my books. So, so I hope I can encourage them to look at that.
All right. Well, thank you for coming on. I know it's you're probably busy, very busy right now, or at some point working on books and things like this. So I appreciate you coming on, and I'd be glad to maybe do another show in the future on another topic, or maybe expanding on some of the stuff in here.
Great. You're welcome. I've enjoyed it. Very good discussion.
All right. God bless everyone, and I'm going to end the broadcast. And thanks for watching.